Now for GP, you need to know how to solve indices very well. Indices, exponents. All the formulas for indices should be used very well over here. Yeah. Okay, so here again you have a formula to find the nth term, Tn. What's the formula for Tn? It's A r raised to n minus 1. Okay, A stands for the first term. R is the not difference, but the ratio between two consecutive terms. Okay, so let's take an AP, a GP, 2, 4, okay, then 8, 16, 32. This is a GP. So it doesn't have a common difference, okay, but it has a common ratio. Means if you do 4 upon 2, what is 4 divided by 2? 2. Or 8 divided by 4? 2. Or 16 divided by 8? 2. Okay, so that's why it's called ratio. A is the first term, n is the number of terms. Okay, so this is the formula to find the nth term. Then next, to find the sum of n terms, there are basically two formulas. Okay, there's three, but the middle one is of no use. So you have two formulas. One is if r is greater than 1 and one if r is less than 1. Okay. If r is greater than 1, not exactly r, but the absolute value of r. Absolute value of r means ignore the sign. For example, the number minus 2. Is this greater than 1 or less than 1? Huh? Is minus 2 greater than 1 or less than 1? Yeah, in actual maths, minus 2 is less than 1, right? But that's not what they're asking. They're asking the absolute value of minus 2. Is that absolute value means you remove the sign. So if you remove the sign, what do you get? 2. Now, is 2 less than 1 or greater than 1? It's greater than 1. See, first time, if we did not look at the absolute value, we would think it is less than 1, right? But that's not what we're looking at, okay? You're seeing the absolute value. Okay, so if the absolute value of r is greater than 1, then this is the formula. Sum of n terms is into r is bigger than 1, so r should be written first. R raised to n minus 1 upon r minus 1. See, it's always big minus small. Okay, so r is bigger, no? So that's why r is written first and then the 1. Now, if r is less than 1, that means 1 is bigger. So you just interchange these two. So sum of n terms will be a into 1 minus r raised to n upon 1 minus r. Because here 1 is bigger than r, no? So just so that you won't have a negative sign, think of it like that. You are just interchanging those two. Okay, so these are the two formulas to find sum. Now, this will get a little complex because there are powers. So you have to use the indices laws and all that. So if the question becomes too difficult in this, I just suggest you don't waste your time solving this question. Okay, you leave it. But if it's doable, just do. Don't spend more than 3 minutes in this question. So we'll just do a question. You look at the sixth one. The fourth and the seventh terms of a GP are 1 upon 27 and 1 upon 729. Find the sum of n terms of this GP. The fourth term is 1 upon 27. So T4 is 1 upon 27. Now, how do you represent T4? A r raised to 3. Right? A r raised to n minus 1. So A r raised to 3 is 1 upon 27. Okay, next is what? Seventh term is this. Seventh term is T7. T7 is 1 upon 729. Okay, how do you represent T7? A r raised to 6 is 1 upon 729. Okay, so this is your first equation and second. Now, how do you solve this? It's like simultaneous equation, but there's no addition subtraction. So you don't add or subtract the equations. You'll have to multiply or divide. So we'll divide second equation, divide with the first equation. Okay. So AR raised to 6 divided by AR raised to 3 is equal to this divided by this. There's 1 upon 729 divided by 1 upon 27. Understand? So here what happens, A and A will get cut. R raised to 6 upon R raised to 3 will become what? 6 minus 3. To subtract the powers. So that is R raised to 3 is equal to 1 upon 729. Here we'll convert this division to multiplication and write it as 27 upon 1. Okay. Now, if you know, 27 is a cube of a number. 729 is also a cube of a number. So don't try to cut them because they're already perfect cubes. Okay, so we just write it like this. R raised to 3 is 27 upon 729 and R is equal to cube root of 27 upon 729. What is the cube root of 27? 3. 3 into 3 into 3 is 27. And cube root of 729 is 9. 9 nines are
9.
81. 81 into 9 is 729. Okay, and then you can cut this. The final answer is 1 upon 3. Okay, so we had to use, first was the basic thing, just substituting the value of T4 as AR raised to 3. After that, what you did with these two, simultaneously solving them, not by addition or subtraction, but here we did division. The bigger one divided by the smaller one. That way A and A got cut off and we were able to find R. Okay, but then here we use the indices law. That is when you're dividing, you have to subtract the powers. And then you should know cube roots. Okay, so there's a lot of things you need to know in this chapter. Basics from cubes, cube roots, powers, and indices. Just write this one down, and then I think we should go to the next chapter. Unless you want to solve some more in this chapter. Note down this.